VPC service controls perimeter bridge question. Welcome. Today, we are analyzing a specific VPC service control scenario that tests your understanding of how service perimeters and perimeter bridges work together. This question is about understanding the communication patterns between projects when they are in different service perimeters. The key insight here is recognizing what happens when projects are isolated by service perimeters and when perimeter bridges come into play. We have three projects: dev, stage, and production, each with their own service perimeter. The scenario tells us that stage can communicate with both dev and production, but dev and production cannot communicate with each other. This communication pattern is the clue we need to identify the correct reason for the isolation between dev and production projects. Understanding the scenario. Let me break down what we're looking at here. We have three separate service perimeters, one for each project environment. This is a common enterprise pattern where you want to isolate different environments for security and compliance reasons. The interesting part is the communication pattern. Stage can talk to both dev and production, but dev and production are isolated from each other. This isn't random, it's a deliberate security design. Think about typical software development workflows. You might want your staging environment to be able to access both development resources for testing and production resources for validation, but you definitely don't want development and production talking directly to each other. This pattern suggests that there are specific connectivity rules in place that allow some communication paths while blocking others. Service perimeter architecture. This diagram shows how VPC service controls create isolated security boundaries around each project. By default, when projects are in separate service perimeters, they cannot communicate with each other. Each perimeter acts like a firewall around Google Cloud APIs. Resources inside a perimeter can access each other freely, but cross-perimeter communication is blocked unless explicitly allowed. The key insight here is that service perimeters are denied by default. Once you put projects in separate perimeters, they become isolated islands. To allow communication between perimeters, you need additional configuration. This is exactly what we're seeing in our scenario. Three isolated perimeters with specific connectivity rules that allow some communication while blocking others. Analyzing the communication pattern. Now let's analyze what's happening in our specific scenario. We have stage communicating with both dev and production, but dev and production cannot communicate with each other. This pattern tells us that selective connectivity is being allowed. If all perimeters were completely isolated, stage wouldn't be able to communicate with anyone. Conversely, if they were all connected, everyone could talk to everyone. The fact that we have this specific pattern, stage acting as a hub that can reach both dev and production, while dev and production remain isolated from each other, strongly suggests that perimeter bridges are being used selectively. This is a classic hub and spoke communication pattern where stage acts as the hub, and dev and production are spokes that can only communicate through the hub. Understanding perimeter bridges. Perimeter bridges are the mechanism that allows controlled communication between separate service perimeters. They create secure tunnels between perimeters while maintaining the security boundaries. When you create a perimeter bridge, you're explicitly saying these two perimeters should be able to communicate with each other. Without a bridge, perimeters remain isolated. In our scenario, the communication pattern suggests that there are bridges between dev stage and stage production, but crucially, there's no bridge between dev and production. This explains perfectly why stage can communicate with both environments, but dev and production cannot communicate directly with each other. The missing bridge is the reason for their isolation. Evaluating the answer options. Let's examine each answer option to understand why option D is correct. Options A and B about VPC accessible services don't make sense here. VPC accessible services is about allowing access to Google Cloud APIs from within VPC networks, not about cross-perimeter communication. Option C suggests there is a perimeter bridge between all three projects. But if that were true, then dev and production would be able to communicate, which contradicts our scenario. Option D states there is no perimeter bridge between dev and production projects. This perfectly explains our communication pattern. Stage can reach both because it has bridges to each, but dev and production cannot reach each other because there's no direct bridge between them. Why option D is correct? Option D is the correct answer because it directly explains the observed communication pattern. The absence of a perimeter bridge between dev and production is precisely why they would be unable to communicate. In VPC service controls, perimeter bridges are required for cross-perimeter communication. Without a bridge, the perimeters remain isolated from each other, regardless of any other configuration. The scenario we are given, where stage can communicate with both dev and production, but dev and production cannot communicate with each other, is only possible if there are selective bridges in place. Specifically, there must be bridges connecting stage to dev and stage to production, but no bridge connecting dev directly to production. This creates the hub and spoke pattern we observe. Real-world implementation. This type of configuration is actually quite common in enterprise environments. Organizations often want their staging environment to have broader access for testing purposes, while keeping development and production strictly separated. From a security perspective, this pattern makes perfect sense. You don't want developers accidentally affecting production resources, but you do want your staging environment to be able to validate against both development and production-like resources. The perimeter bridge configuration allows you to implement this policy at the infrastructure level. You can ensure that the communication patterns are enforced by the platform itself, not just by application-level controls. This demonstrates the power and flexibility of VPC service controls for implementing sophisticated security architectures in cloud environments. How to configure perimeter bridges. Let me show you the actual commands you would use to create this configuration. Understanding the implementation helps reinforce the conceptual understanding. First, you would create your 3 service perimeters for dev, stage, and production. Each perimeter would contain the respective project and define which Google Cloud services are protected. Then, to enable the communication pattern we see in the scenario, you would create perimeter bridges between stage dev and stage production, but deliberately omit creating a bridge between dev production. The commands shown here demonstrate how to create these selective bridges. Notice that we're creating 2 bridges but not the third one that would connect dev and production directly. Summary and key takeaways. Let's summarize what we've learned from this scenario. The key insight is understanding how perimeter bridges control communication between service perimeters. Service perimeters are isolated by default. Communication between perimeters requires explicit perimeter bridges. The presence or absence of these bridges directly determines which projects can communicate. In our scenario, the communication pattern, stage can reach both dev and production, but dev and production cannot reach each other, can only be explained by selective bridge configuration. The correct answer is option D. There is no perimeter bridge between the dev and production projects. This absence of a direct bridge is exactly what prevents dev and production from communicating while still allowing stage to communicate with both through separate bridges. This type of hub and spoke architecture is common in enterprise environments and demonstrates the sophisticated access control capabilities of VPC service controls.